Hello everybody, so this is another calorimetry problem. We're given 1.567 grams of naphthalene, and we're being told that the temperature increase is 8.37 degrees Celsius. And then we're also told that when we add the solution of 1.227 grams of thymol, the temperature increase is 6.12 degrees Celsius. And we're told that for the naphthalene, the heat of combustion is 5,153.9 kilojoules per mole. And then it's basically asking what is the heat of combustion per mole of thymol. And so the way to attack this problem is to, you have to first set up your equation. You want to find, you know that it's Q equals MCAT, right? But right now we're just going to be solving for the heat capacity because we're given heat per mole. What we can do is we can convert our 5,153 kilojoules per mole, and we can convert it just to kilojoules. So to do that, we have to take our 1.567 gram sample and then divide it by its molecular weight, which is 128 grams, and then multiply that our 5,153.9 kilojoules per mole by this quotient, and we'll get 63 kilojoules. And we know that is going to be our heat, but we're not setting it equal to MCAT now because we divided out our masses solving for the problem. So now it's our heat is going to be equal to the heat capacity times the change in temperature. We're given the change in temperature as being 8.37 degrees Celsius. So we can divide 63 by 8.37, and we get, I think right here, I don't know why I drew that, just ignore that. We get 7.57 kilojoules per degree Celsius. Okay, so that's our heat capacity. Next thing we want to do is we want to find the heat that's emitted from thymol. And we know that it's going to be in the same solution, right? They're being added to each other. So the heat capacity is going to be 7.57 times the change in temperature in the solution, which is only 6.12 degrees Celsius. So we get our heat is equal to 46.3 kilojoules for the solution. Now we have to divide that by the moles of naphthalene that was added. So to do that, we have 1.227 grams of, not naphthalene, sorry, of thymol added. We have 1.227 grams of thymol divided by its molecular weight, which is 130, and we get 9 times 10 to the negative 3 moles of thymol. And so we divide 46.3 kilojoules by 9 times 10 to the negative 3 moles of the thymol, and we get 5,144 kilojoules per mole of thymol added, and that's what the question's asking. Okay, so that is tackling those types of problems. If you have any more questions, feel free to email me, gforbes@poets.whittier.edu.